As you've learned, your magnetic compass works by aligning itself with the Earth's magnetic field. And you've also learned that although the compass is very simple and reliable, there are some inherent errors to deal with. Magnetic lines of force not only work parallel to the Earth's surface, but they also contain a vertical component that becomes more pronounced as you move away from the equator. This vertical component, or downward pull, called dip, becomes more of a factor the closer you get to either pole. Your compass not only wants to point to north, but it also wants to dip down to the Earth. Normally in cruise flight, dip is not a problem because the magnet in your compass is weak, as are the Earth's lines of magnetic force. There's not enough strength to make the compass dip down. Also, due to the way the magnet in your compass is mounted, it normally can only rotate left and right on its axis. So your compass does not have any dip errors in straight and level, unaccelerated flight. However, dip can create errors if the compass axis is changed. Let's see how dip comes into play so we can predict when these errors will occur. First, let's look at what we call acceleration errors. What happens to the hot latte in the cup holder of your friend's fancy sports car when he stomps on the accelerator? It slops over the back rim of the cup, right? And suppose you've just installed some new front brake pads on your 10-year-old beater car. What happens to the scalding hot cup of decaf French roast you're holding when you stand on the brake coming out of the parking lot? This time, it went right over the front rim of the cup onto your lap, didn't it? Well, the same sort of back-front thing happens to the compass fluid and card. When you accelerate or decelerate, they tilt. Now, if you happen to be flying on a generally east or west heading when you speed up or slow down, the magnetic needle, which is still aligned north and south, is perpendicular to the direction the compass fluid and card are tilting. Tilted like that, the downward pull of dip can now make the card move, and your compass shows a turn to the north or south, which isn't really happening. In the northern hemisphere, you can predict the direction of the false indication with the mnemonic ANDS. If you accelerate, your compass will show a turn to the north. If you decelerate, the apparent turn is to the south. No such word, you say? Well, there are no ands, ifs, or buts about it. There's no action required on your part. You should just know it's happening and that your compass will be accurate as soon as your speed steadies. Now, you won't get acceleration errors on a north or south heading because when the magnetic needle is being tilted up or down, it's still parallel to the lines of magnetic force. This means it won't rotate to one side when its axis is tilted. Now, back in your Skyhawk, what happens to the coffee in your instructor's cup when you make a perfectly coordinated ball-in-the-middle turn? Not only doesn't the coffee spill out of the cup, in fact, the surface of the coffee remains parallel to the cockpit floor, but the surface of the liquid is slanted with respect to the Earth. The same thing happens inside the compass. In a bank, the float slants with respect to the Earth, and dip does its thing, pulling the north end of the magnet toward the low side. This is called turning error, and it's at its worst when turning in the vicinity of north or south headings. In the northern hemisphere, if you're on a northerly heading and you start a turn in one direction, the compass momentarily indicates a turn in the opposite direction. So some pilots use the mnemonic NO for north opposite. And if you were starting your turn from a south heading, the compass would jump ahead, showing a faster turn than you were actually making. The turning errors disappear in the vicinity of east or west headings. If you're in the 48 contiguous states, the rule of thumb for dealing with this is when turning to north, stop your turn before reaching north by about 30 degrees. And when turning south, continue the turn about 30 degrees beyond south. In either case, after you level your wings and the compass settles down, you'll be on the desired heading. If you're close to Mexico or the Gulf, you may need a few degrees less, and up near Canada, a few more. After all, it's just a rule of thumb. Another mnemonic, COSN, tells you the error to expect and helps you remember which way to apply the correction. It stands for compass overshoots south, undershoots north. By the way, the rules work just the opposite if you're flying south of the equator. So now you know that magnetic dip is not a personality trait, or at least not one of our personality traits. Although dip will cause errors in your compass, now you won't be surprised by them.